Welcome back, folks. This is section 6.1, a little subset of a problem type that you will see possibly on the AP exam, definitely in WebAssign. I like to call it splitting a region in half. Okay, this is kind of a supplement to our area between two curves discussion from section 6.1. So we start here with the shaded region shown to the right. It's bounded by the graphs of y equals x squared, x equals 4, y equals 0, and it is this region right here. So that's the region we're working with right now. Question 1 says the vertical line x equals a splits the region into two equal areas. Write an equation involving one or more integrals whose solution gives the value of a. By the way, this type of question often appears on the AP exam, slightly different than what we're going to see in part 2, but let's talk about it. So we got a vertical line. I'm just going to sketch one in here, and that's going to happen at x equals a, and that's splitting this region into two equal pieces. So that means this yellow highlighted portion has to be equal to the green highlighted portion. Before we get too far into this, let's go ahead and find out what that total area is. That total area is going to be the definite integral from 0 to 4 of x squared dx. The antiderivative there is x cubed over 3. I got to go from 0 to 4. That means I'm going to plug in 4 and cube it. I'm going to subtract 0 from that. And that gives me, let's see, 4 cubed is 64. That gives me an area of 64 over 3. Okay, so that original shaded area, the total, was 64 thirds. Okay, so let's talk about what half of that is. 1/2 of that area is 1/2 of 64 over 3. Let's see, that's going to be, let's do a little quick mental math here. That's going to be 32 over 3. Okay, so that's half of the original shaded area, and I have to find that vertical position, x equals a, that splits the region in half. So the first part of this says just all we have to do is write an equation involving one or more integrals whose solution gives the value of a. So there's actually 3 different equations you could write here to get full credit. You could do this one. Okay, so that would be equal to the integral from 0 to a of x squared. That would be equal to what I have shaded yellow in the figure. And then we could set that equal to 1/2 of the integral we just found. Okay, and we already know that that's equal to 32 over 3. Okay, so that one equation there, you don't even need this middle piece. So you can just say the integral from 0 to a of x squared dx is equal to 32 over 3. That would get you full credit. I want to leave that. Original expression in the middle there just to show where that came from. So that's one possibility that'll get you full credit. Here's another one. Okay, so I could set up an integral for that green shaded region, and that would be the definite integral from a to 4 of x squared dx is equal to 1/2 of that integral, the total integral, and we know that's 32 over 3. Okay, so that's another option, and again, that would represent, that integral right there represents the green shaded area. There's a third one you could set up here, and I'll let you kind of analyze this one to see why it's equal. It just says write an equation. It doesn't say specifically what your thought process needs to be. You could do this. Okay, so that kind of is a combination of the two previous ones. This integral from 0 to a of x squared is equal to the yellow shaded region, and the integral from a to 4 of x squared would be the green shaded region. So you can also write that third option there and get full credit. So there's 3 choices you have there to write that equation involving one or more integrals whose solution gives the value of a. All right, so let's now jump to part 2. In part 2, I want to highlight this for you. AP questions typically don't ask for this, this part to actually find the value of A, but I believe in WebAssign there's a couple of problems that do require it. So let's go back to, we might as well take a look at this first equation. I'm just going to copy this one down, and we're going to solve that equation algebraically. So we have the definite integral from 0 to A of x squared dx. Hold on, folks, you deserve better than that. It's getting a little sloppy. Definite integral from 0 to A, x squared dx, is equal to, I'm going to go with the 32/3. Okay, so let's go ahead and evaluate the left-hand side of that. I'm going to have x cubed over 3. I have to go from 0 to A, and that's going to be equal to 32/3. Okay, so that means I'm going to plug in A. I've got A cubed over 3 minus 0 cubed over 3 has to equal 32/3. And let's go ahead up here. Notice that I have a 3 in all of those denominators, so it's equivalent to this. A cubed has to equal 32. And I know some of you are like, wait a minute, that you jumped too many steps there. Well, this term right here is just 0. So then I have A cubed over 3 equals 32/3, but divided by, I'm just going to multiply through by 3, and that gives me A cubed equals 32. So we're going to go with that, and then I'm going to take the cube root of both sides. A is equal to the cube root of 32. And I'll just warn you, when you do this, if you did this problem on your calculator would give you a different form of answer. Okay, it would look like this. It would give you 2 times 2 to the 2/3 power. Okay, and that's equivalent to the cube root of 32. Let me just step you through real quick to show you how those are equivalent. I have 2 times 2 to the 2/3 power. That's the same as 2 to the 1st times 2 to the 2/3. Okay, so I have 2 powers of the same base. I can add the exponents. The product of 2 powers with the same base, you can add the exponents. 1 plus 2/3, that's 5/3, so this is equal to 2 to the 5/3 power, which I can rewrite that denominator, the 1/3 power is a cube root, and then this would be 2 to the 5th. And last time I checked, 2 to the 5th is 32. So we're running out of space here. Cube root of 32. So that's just a little fun with algebra to show you that they're equivalent. Okay, now let's jump into part 3 of this problem. So the horizontal line y equals b splits the region into 2 equal areas. Write an equation involving one or more integrals whose solution gives the value of b. Little note here for you. This one's harder than the first one, okay? And I'm going to sketch the graph here, and maybe that'll help illustrate why. So I'm going to go ahead and sketch in. There's our y equals x squared. We had the line x equals 4. And that shaded region, we know that area was equal to 64/3. Okay, so now we don't have a vertical line anymore. We now have a horizontal line, y equals b. So that thing's going to come in here. I'm just going to take a guess at where I think that'll fall. It's going to look something like that. Okay, so y equals b. And now what I have to do is I have to find b such that that region right there is equal to half of a. And we already said from the previous problem, half of a is equal to 32/3. So I have to set up an equation such that that yellow region is equal to 32/3. And take a look at that thing. If we're thinking about our analogy of the integral's a meat slicer, how are we going to slice this so that I intersect 2 different curves with each slice? Well, I now have to slice that thing horizontally. So that means I need to set up an integral with respect to y. Okay, and I'm going to have to do right minus left there. So that means I need that y equals x squared. I need to transform that into x equals some function of y, and that's going to be square root of y. Okay, so let's take a look here. I'm going to do the definite integral from 0 to b of, I'm going to do right minus left, 4 minus root y, that's my integrand, dy, and that has to equal half of the area, 32 over 3. Okay, so write an equation involving one or more integrals whose solution gives the value of b. There it is. I could do the same thing I did in the previous problem where I wrote three different equations. Like, for example, I could also do one where I integrate from b to, let's see, when does y equal x squared there? That would be up here at a value of 16. So I could integrate from b to 16 and set that equal to 32 thirds. Or I could put the yellow and the green integrals and set those two equal. Last but not least here, it says to find b. So I'm going to give you a heads up. Let's just take a look at what happens with this integral when we try to evaluate it. So I'm going to go from 0 to b. 4 minus y to the 1/2 power, set that equal to 32 over 3. So that's going to be 4y minus, let's see, y to the 1/2 becomes y to the 3/2, 2/3 y to the 3/2 equals 32 thirds. I forgot to show my limits of integration there from 0 to b. So we now get this equation, 4b minus 2/3 times b to the 3/2 power, and we set that equal to 32 over 3. And friends, there's not enough algebra that we've ever learned to actually solve that, so we're going to rely on our calculator for that. Let's jump over here and take a look at the calculator. Okay, I'm going to go ahead and set up the, use the solve command with my calculator here. We're going to go menu, algebra, solve, and I'm going to go ahead and use the integral expression, not the antiderivative with the limits of integration substituted in. So I'm going to solve here. We want to go definite integral from 0 to b. Our integrand was 4 minus the square root of y. We're integrating with respect to y, and we want to set that equal to 1/2 the area, which was 32 divided by 3. I now need to tell my calculator what I'm solving for, and in this case I'm solving for that unknown quantity b as in boy, and I grip it and rip it and hope I get a nice answer. Okay, so let's see, we got two answers here. One of them kind of makes sense. If the b equals 4 makes sense to me, but that b equals 29.8564 makes no sense. So let's take a look at what's going on there. I'm going to jump back over here, and we got two answers. We got one answer of b equals 4, which seems to be correct. I know that b's got to be somewhere on this interval here between 0 and 16, so we're going to go with the b equals 4. But what does that other solution represent? The one that was, up in the high 29s there, up almost close to 30. So what that represents is if this integral was to continue, and if we continued with that y equals x squared graph and that x equals 4 graph, and we were doing 4 minus the square root of y, this quantity here, we would start to accumulate a negative quantity. So that would be looking at the total area from 0 to 16, and then it would start to accumulate a negative quantity until it got back down to that half value of 32 thirds. So that's what that extra solution is. Certainly we're not going to report that one. We're going to report b equals 4, and that is the end of this video.